Okay, so what I'm going to explain in this video is why is the mod divided, okay, when that highest common factor is not equal to 1. Okay, so we spoke about that scenario and how many solutions it's going to give and how do we solve, but why do we actually have to divide the mod? Because I hadn't explained that yet. Now, this is not a formal proof, but it is just sort of the logic behind it. Okay, so if we have a look at this congruence relation here, which I did solve in a previous video. Now, how we solved it was we found the highest common factor of the 6 and the 10, which we found to be 2, and we checked that 2 was a factor of 8. So we knew there was 2 incongruent solutions. So I said the next step was to go through and divide everything by 2. Now, one way of thinking about this congruence relation is that 6x subtract 8 is a number. Okay, it's a whole number. So it's either going to be prime, or we can write it as a product of its prime factors. Okay, it's prime factorization. Now, according to this congruence relation, 6x subtract 8 is divisible by 10. Okay, so 10 divides 6x subtract 8. So that means we should be able to obtain 10 by multiplying together its prime factors. Now, if we decompose 10 into its prime factors, we get 2 times 5. So therefore, in the prime factorization of 6x subtract 8, there must definitely be at least 2 to the power of 1 and at least 5 to the power of 1. Now, the powers of 2 and 5 might be higher. There might be some other factors in there. But all I can figure out based off the congruence relation is that 2 and 5 are definitely in there. Now, when I'm solving the congruence relation, I go through and I divide everything by 2. So essentially, I go to 6x subtract 8, that number, and I divide it by 2. So that would give me 3x take 4. And then I must also divide the prime factorization by 2. So that's going to cancel out this 2. So I'm left with 5 times whatever other prime factors are in there. And if we look at what we've got left, this 3x subtract 4, this number, the only thing we can be sure is a factor of this number is 5. Okay, we can no longer be sure that 10 is a factor because the 2 is no longer in there. For some values of x, 10 may well still be a factor, but not all of them. Okay, so therefore, we'd have to go to mod 10 and actually divide that by 2 to change it into mod 5, as that's the only number we're sure is definitely a factor.